right, so this is the new electrical service. Way up there, you can see the new transformer. So they put this in. They had to do a bunch of jackhammering because it's a lot of rocks here. Right now, there's no meter in, so it's not live. There's another inspection that has to get done before that'll get turned on. But everything is wired up. So we've got two 200 amp breakers. So this is where the power, sort of the demarc, right? So like power company's problem, my problem. So I had to set that up, install the conduit, and run the direct variable cable all the way back. I got to fill in the trench now, but this 200 amps goes to the house. This 200 amps goes to the shop. That is a lot more power than the house currently has. Right now we only have 100 amps of service, and it's via an overhead line. Not a fan. All right, so this is the current 100 amp service for the house, and as you can see, it's an overhead line. There's trees. I have to make sure that that's trimmed back and not damaged, etc. Thankfully, this lower one is just phone line, because otherwise that would be a little scary how close that is. But on the other side of it is the guest bedroom, and that's where the current main panel is. Once I have everything hooked up for the new service, I'm actually going to have conduit that runs all the way here, and then the power company will come out, they'll pull the meter, they'll pull the wires, they'll pull all of that, and then I'll replace this box with just a regular box. The conduit will come in and then go to the panel, which will then be the new sub panel for the house. All right, so the 200 amps that's coming from the meter pedestal comes here to the house, and by code now you have to have these emergency disconnects on the outside of residential structures. It's in this case just a 200 amp breaker, just like normal. Pretty straightforward, but yeah, so the direct barrier cable comes up out of the ground, goes into this, and then on the inside of here into the garage. This is connected to underground conduit, which runs over to there, where I'll put a box. And then from there, it runs again under the ground and over to the shop. Alongside it is the direct barrier cable for the shop's power. So this is going to be for solar panels in the future. When I put solar panels up on the roof of the shop, I'll be able to pull the wires for them all the way through that conduit into here and into the garage and connect it to the inverters. This is where power comes into the garage. So that's the 200 amp circuit to the house. It's got 2-watt cables. So you got hot, neutral, and then the ground. It goes through the top 2-inch PVC conduit there over to the grid boss. So that's the brains of the system. It's also called a microgrid interconnect device, or MID. In this case, I do have this is an optional thing that you can do here, but putting in a 200 amp breaker, otherwise you can just connect straight to it. It's not really necessary since I do have the breaker out there, but it just seemed like a thing to do. I don't know. I might be required by code to have it because this would then be the service disconnect, whereas outside is the emergency disconnect. I don't know. I just like having more options. But anyway, so we've got the neutral bus bar, we got the ground bus bar. Again, not connected, right? Because there's only one place where we bond them, and that's back at the meter pedestal. So grid power comes in here, and then we've got what EG4 calls the smart ports, and then the hybrid inverter ports, which are just, again, breakers. So this one is 90 and 90. So this one goes to inverter 1, and that one goes to inverter 2. And I've helpfully labeled them because I like label makers. This port up here goes over to the Tesla wall charger. Mostly just so I can easily see, how much power is being used by it. And also I can set up rule sets with the mid, so I can say if the batteries are too low and the grid's down, turn off power to that. So that way it's not, draining the batteries even further. In the future, I might get a generator, like propane or gas generator or something like that. In that case, I can put a breaker here, and the mid can also be configured like, oh, the grid's down, the batteries are low, turn on the generator, and then, you know, once the batteries are at some level, I can say, okay, turn the generator off again. This thing is great. This basically simplifies all of the electrical setup, because like normally with like an inverter setup, what you have to do is, you know, the power comes in from the grid to the inverter and then like out from the inverter to your loads, which starts getting a little bit more complicated when you've got multiple inverters. But in this case, everything's handled by this, and there's a lot less wiring needed. So like in the case of the inverters, the only real wiring needed is the connection to the grid boss, and then the connection to the batteries. I don't have to do, you know, connection from the grid and then to the loads and all that. That also allows me to use these FlexBoss inverters, which are a little bit cheaper because they lack basically like bypass relays and stuff. So you could say like, oh, you know, I want to use power from the grid to send it to my load, but take the inverter offline temporarily so I can, you know, do maintenance or whatever. Just it makes things a little bit easier and nicer in my opinion. Let's see. So yeah, this is what the grid bus looks like on the outside. It's got LEDs here to tell you like what's going on. So you can see like generators running, grids up, hybrid inverters are on, etc. This is the house main panel. Now this breaker here, right now it's a 70. It's actually going to get swapped out for 100 amp because I'm going to be putting in some conduit, the 1.25" conduit. And it's going to run all the way outside and around the house to the old main panel. And so the old main panel will be a sub panel of this one once I swap over the service. I've got just a basic like utility outlet here. Primarily, I put that on there so I can install what's called an iota watt, which, you know, you clamp it onto your wires, and it allows you to you know, have a nice data logging of like what circuits are drawing, you know, how much current, etc. And so it gives you a good idea of how much everything is using, right? So if I have it on like every circuit, because I'll put another iota watt over on the new sub panel. And I'll be able to say like, oh, the refrigerator drew this amount of kilowatt hours this month, things like that. The other breaker here, this 30 amp, this is actually connected to a surge suppression device. So whole home surge suppressor. This is the HEPD 80. I went with Square D for basically everything. No particular reason. I just tend to go with Square D stuff, and in particular the Square D QO. So like this panel is the Square D QO 200 amp panel. It's got plug-on neutral, which means it's for AFCI and GFCI breakers like this. I don't actually have to put the neutral to like the neutral bars or the ground bar. It goes into the breaker, and AFCI and GFCI, that's arc fault and ground fault. So if there's like a break in the wire or something and it's arcing, this will detect it and turn off. If it's if there's a ground fault, i.e., you know, the toaster in the bathtub problem, it'll trip. Hopefully save you from that. Don't try it. But yeah, like these are neat. I haven't actually used any of these AFCI breakers really before, but hopefully they work great. They are required by code for a lot of places in homes now, so why not? If I run into problems, I can always swap it out for like a regular GFCI breaker or a non-AFCI GFCI breaker for the parts of the house where that's allowed. So like I think the garage, it might only need to be GFCI. The surge suppressor, so these things are neat. Basically, if there's a spike in like voltage, this is going to, as quickly as it can, try and shunt that energy to ground. So in this case, yes, it's a 30 amp circuit and these are pretty small wires, but it's not actually carrying a lot of current. Its job is just to be connected to the two lines that are coming in and shunt stuff to ground as needed, right? So it's got, you know, the lives, the neutral, and then the ground. The shorter those wires are, the faster it can work, basically. The way I've always thought about it is like the pulse, you know, like if there's a a surge, right? It's going to come in, it's going to start traveling down all the wires equally until it gets to the surge suppressor, which will then send it to ground. And so if it gets to the surge suppressor, if the distance to the surge suppressor is shorter than the distance to, say, something you care about, this will mostly protect it. Whole home surge suppressors are not like a, like magic bullet. It doesn't like mean that you don't have to do anything for any of your like sensitive equipment. Still put a like UPS on your computers, or like a basic power strip with a surge protection for like your TV and stuff, right? Like, just, they're like $20 tops or something, right? Like, it's just a nice peace of mind, defense in depth, right? Surge suppression at the panel, surge suppression at the device, etc. This is where the power is coming in from the mid. So from the Grid Boss, that's the backup loads port here. This is the non-backup loads port. I'm not going to be using that at all, so there'll never be anything connected to those. That's basically just, you can see it here. So the non-backup is connected always straight to the grid, and that's it. It's not ever connected to like the the inverters and things like that. So if the grid is down, the non-backup port just doesn't have power. I don't have a need for that, at least with my setup, so nothing connected to it. Let's see. So we've got, main panel, got the microgrid interconnect device, the brains of the system, and then the inverters, right? So the inverters are connected to the batteries. They take the 48 volt DC from the batteries, and they will convert it to 240 volts AC, which is what these lines are, sends it to the mid, which the mid then determines, like, based on conditions and stuff, like, okay, I'm going to draw from the inverters and send it to the house, or maybe I'll draw from the grid and send it to the house, etc. If I had grid tie solar panels, I could actually connect them here to the smart ports. I actually don't have any solar panels at the moment. I plan on having some, but when I do, I'll be connecting them to the inverters, because it's the other function of the inverters. So they can also take power. That's what these terminal blocks here are for. They can be connected to DC solar panels, so not the grid tie solar panels, and they will do the whole like MPPT optimization stuff, so that it'll take your solar panel power and use that to either power your house. Potentially, I can sell back to the grid if I get it set up that way. I'm on the fence on whether I'm going to do that or not. But I can use that solar panel for powering the house or charging the batteries. It can also pull from the grid to charge the batteries. So I've got a lot of options. It's all just settings, configuration stuff. The battery cables are pretty thick. These are 2-watt cables again, and they're really nice cables. So they came with the batteries and an inverter from EG4. They were just barely too short for what I needed. So I did use these butt connectors and then heat shrink tube to protect it. Because the way that EG4 tells you to, set everything up is basically, if you're doing 2 inverters and 4 batteries, you do the 4 batteries and then you do inverter. For cooling reasons, the inverters need a certain amount of space above them, and that is not enough. So what I had to do is put the inverters here. The mid doesn't need as much space, so I have it there. But normally, you have the inverters here and connected to the batteries just below them. Basically so that all of the length of wire between them is roughly the same. I'm not completely sure it makes that big of a difference in the grand scheme of things. I mean, like, it definitely does matter. I just don't know if it matters that much, but I figured why not. So this inverter is connected to that battery, and this inverter is connected to that battery. So it's the same basic setup. I just made the cables a tiny bit longer, but they're all 8 of these cables are the same length, so it still works out effectively the same. The batteries themselves, I've got them labeled. So, 1, 2, 3, and 4. They have this Ethernet cable for communication. And so they're sort of daisy chained together. The screen, it actually has like a touch screen and everything. So when they're actually up and running, you can, go here, hit the touch screen, and very quickly see like, oh yeah, okay, I got 53% of battery. This is battery 1. It's in standby mode, which means it's not powering anything at the moment. You got the green ring here, which I believe roughly tells you what the state of charge is for the batteries. Pretty neat. The screen turns off after 30 seconds. I think that's configurable. I'm not really going to look at these ever. I'm going to set it up with Home Assistant or something and get alerts when the batteries are low. I'm not coming out to my garage, regularly to check the batteries. These cables for the batteries are really neat, in my opinion. So these connectors are, I forget what they're called, but they are like latching connectors. So you just push a button on the side of them to release them, and then like to put them on, they just push down and snap in. The connectors are kind of expensive. They're like 18 or 20 bucks a pop, which is why I was just like, I'm going to just reuse these cables. I'm not going to like buy new cables that are long enough and buy the connectors and then crimp them. And yeah, that was going to be like a couple $100. So no. So in this case, since this is battery 1 and you configure the battery identification with these little dip switches back here. I'm not sure how well it's showing up, but little dip switches back here. Actually, I can show it over here. No, it's not any better. But yeah, so there's dip switches there, and that determines what ID each battery has. So it's just binary, right? So this one is 1. This one has the second one set, so it's 2. This one has 1 and 2 set, so it's 3. And then this one has the third one set, so it's 4. If you don't know binary, I don't know, look it up. I'm not good at explaining this in a video. So the batteries, as far as I'm aware, communicate between each other using RS-232, which is serial. The battery and the inverter, so this is the primary inverter or the master inverter, it's the only one that's actually connected to the batteries for communication. So in this case, it's connected via CAN. And this inverter is responsible for talking to the battery setup and just saying, finding out like, okay, what's the status of the batteries? Are they currently allowing themselves to be charged or discharged, etc. It also allows the batteries to report like what the state of charge is, so I can make decisions. Because the inverters are via these two links connected together and to the grid boss, and they pass along that state of charge information. So I'm able to make decisions with the rule sets in the grid boss based on the state of charge of the batteries, rather than just having to go off of like the voltage of the batteries, which isn't as accurate, to tell you like whether the batteries are charged or, mostly empty, etc. State of charge is a much better way to handle that, but you have to talk to the BMS to get that information, because the BMS is constantly monitoring, the amount of power coming in and out of the batteries. Let's see, what else we got? I got the covers off right now, just because it made it a lot easier to work with all the cables instead of me having to they're on little hinges. So I kept having to work around them, and that was super annoying. So I just took them off. I'm going to put them back on in a minute. Let's see. Oh yeah, the batteries. So the bus bars up top, that the positive and negative are connected to, those are off right now, but once you flip this DC breaker on, it connects the battery cells to the bus bar there. Sorry, I'm talking really fast. Right now I have them off because I don't have grid power hooked up, so I'm not going to be running the batteries and draining them down to 0 until I can have a chance to actually, charge them. I don't want to kill the batteries before, I can even use them. Which reminds me, let me turn that one off. But yeah, that's the house in a nutshell. It's not actually all that complicated. Well, okay, I say that. I've spent a lot of time reading the manuals and all that. I'll put up a link to a diagram showing how I have these wired up, but the basic gist is the batteries are paralleled together. That battery has connections to inverter 2, that battery has connections to inverter 1, and then the AC lines connecting them to the grid boss. Here's another shot of the sort of schematic of how things work internally with the grid boss, right? So grid power comes in, it's got relays for like connecting and disconnecting, you know, the grid and the generator as needed, relays for connecting and disconnecting the smart ports as needed, etc. Yeah, it's taken a lot of work, but I'm just really excited about it. I got to play around with the Unistrut, or just strut. So like the batteries are all hooked into the wall via that. So I've got beefy washers. They're all sunk into the studs, and then the batteries and the inverters and grid boss and stuff are connected to the strut. So it's all like super solid, not going anywhere. Just for like peace of mind stuff, we had it laying around. We put some of this cement board behind it because it marginally improves the fire safety. I'm really hoping that never becomes an issue, because like battery fire and electrical fire would be bad, especially considering like above here is the bedroom. Yeah, that'd be really bad. But why not, right? It had cement board laying around, so I did it. Been using the 2-inch PVC conduit for pretty much everything. So this second conduit is currently unused. That's where, when I get the solar panel set up, I'll have them come back in through this conduit, and then they'll be able to go up and to the inverters. So they'll come out of this one. It'll go, I believe, through this conduit. I got to go double check my notes. I had to do conduit fill calculations for each of these to make sure that I'm not putting too many wires or too big of wires in each of the conduit runs. Some of you may have an electrical background and may go, well, but if you've got multiples going through a conduit, don't you have to derate them? That's what I thought. I did some more research, etc. If the conduit run, or I guess the raceway is what they call it, if it's less than 24 inches long, then I don't have to do that derating based on the number of current carrying conductors, which is good, because otherwise I was going to have to upsize a lot of this stuff, and that was going to be a pain. But yeah, if y'all have questions, obviously just, put them in the comments, man. I'll read them. I'll answer them best I can. If the questions are kind of complicated and require a longer answer, then I'll just do a follow-up video. But yeah, that's the house side. So I guess let's go look at the shop side next. So on the shop side, we have the emergency disconnect, just like on the house. And then this is where the conduit comes in. I just reused another one of these boxes because it's going to connect the solar panels that eventually go up on the roof. Will then get fed in through here. But also if I run like Ethernet cable or something from the house, I'm going to have it come through this same conduit, and then it'll just connect into the inside of the shop. So come around here, don't mind the mess. So this is the shop main panel. We got the power coming in from the meter pedestal here. This is going to be the surge suppressor, just like in the house side of things. This is a 50 amp circuit that's going to go to this NEMA 1450. And this is the EV rated. So the contacts are designed for a lot more like plug-unplug cycles and for higher constant current. I mostly have this for like welders and stuff, but why not go with the beefier plugs? And then I'll have a 4-quad there on that 20 amp circuit. In the future, I will also have like lights and everything tied into this, but I just need to get something up and running so I can get it inspected, get the power turned on, etc. And then I can pull another permit later when I know where I actually want to put all the outlets and stuff. So for grounding out here, the shop is a metal building, and I've got a U for ground. So it's this is rebar that's tied into all the rest of the rebar that's in the slab, and then that's going to be my ground point. Just like in the house, it's not the neutral and the ground are not bonded here because they get bonded out at the meter pedestal, and it's the only place they get bonded in this configuration.